Good day, everyone. I welcome you all to this lecture. For this video, we are going to discuss the evolution of computed tomography scanners. We are going to discuss one by one the different generations of CT scan, and we are going to know how they function, what are their advantages and disadvantages. We will start with the first generation clinical CT scan. So Hounsfield's original 1971 scanner was known as the first generation CT scanner, and this used a collimated pencil beam of X-rays to acquire a single data point at a time. So this collimated pencil beam of X-rays measures 3 millimeters wide along the scanning plane and 13 millimeters long across the plane. So it is very slow. It is slow scanning, and it would take around 5 minutes to complete one scan. So one scan refers to 180-degree rotation. So this generation of CT scan has a mechanism of rotate translate. Rotate translate means um, after after giving after giving off X-rays here, after one scan, it will rotate a degree, so 1 degree rotation, and then it simultaneously it will translate the data. So it will complete a 180-degree rotation. So after a scan, after giving off X-ray, then it will move a degree, 1 degree, and then translate simultaneously, then X-ray again, and then rotate. So it will complete 180-degree rotation. The drawback for this generation of CT scan, it has a very long scanning time. It would take 5 minutes. 5 minutes is required to complete one scan, so very long. However, this generation of CT scan is very efficient in rejecting scattered radiation. So, um, kahit matagal ang scanning time niya, effective naman siya in rejecting scattered radiation, and ma, 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 ma-lessen ang dose ng patient, di ba? Radiation dose ng patient if efficient ang pag-reject ng scattered radiation. So the first generation scanner represented a good proof of concept for CT as a technology. But, as demonstrated by the poor quality shown in the brain scan image, the scanner was limited in its ability to provide a representation of the patient's internal geometry. So as you can see here, this was the first clinical scan of a patient with a frontal lobe tumor taken on October 1, 1971. Yes, we could see the head of the patient, but very poor ang quality. You couldn't even clearly recognize the brain, 'di ba? So, yan lang ang ano. So, the low quality of this scan was attributed to the patient's movement during the 4.5-minute scan time. So, ang poor quality na image isn't just with attributed to the current generation of CT scan, but also ang big factor din ng poor quality image was the patient's movement. Because I know it is very straining for a patient to stay still for 4.5 minutes or 5 minutes during a scan, di ba, without moving. So eventually, the patient would move. So that is why we have this low quality image. So to reduce scan time, since yan man ang main problem or main drawback ng current generation na ito, to reduce scan time, the second generation CT scan was built. So let's move on to the second generation. So this generation of CT scan has a mechanism of still rotate translate, but now um, multiple pencil beams oriented at different angles. There are now multiple pencil beams. Hindi na siya pencil beam, single pencil beam, but multiple, which are oriented at different angles, which allowed a reduction in number of rotation steps required. So, ang rotation na niya is 6 degrees na. So, na-reduce na ang scanning time. So, it would require na lang, anyway, by the way, ang, when you say multiple detectors, so this generation of CT scan has a design of narrow fan beam with multiple detectors, which are 5 to 30 detectors. So the 1975, this was in 1975, this was released by the ME, the company that Hansfield worked, and ME released this second generation scanner that was able to acquire a scan in less than 20 seconds, diba? Through the use of 30 separate pencil beams. So the 20-second threshold was particularly important in clinical CT, as 20 seconds is a small enough amount of time for a patient to be able to hold their breath, and so problems related to patient motion could be considerably reduced. Yun. So since marami naman ang detectors, eventually bababa din yung scan time. But the major drawback of this generation is there is also increase in scatter radiation. So in third generation CT scan, it has a mechanism of rotate. Why rotate? So we will discuss that. So in third generation clinical scanners, An array of detector an array of detector cells is placed on an arc opposite an X-ray source, emitting a fan of X-rays that encompasses the whole patient within the field of view of the fan. So in this third generation setup, the source, the X-ray source, and the detector remain stationary with respect to each other and scan by rotating around the patient. So that is why it's called rotate because simultaneously or sabay-sabay, the X-ray source and the detector array would rotate. Yan. So sabay sila. It has also multiple detectors. Yan. So as the first designs required cabling to transfer signals, and so significantly limited to rotation of the scanners, this limitation therefore required scanners to rotate alternately clockwise and counterclockwise to acquire slice data, which then limited the lowest slice time to approximately 2 seconds. So, diba? Because the X-ray source or the X-ray tube needs electricity, therefore, back then, meron talaga yan siyang kalakip na mga electrical wires. So, para hindi matanggal or magkabuhol-buhol yung mga wires, so this generation of CT scan requires the the X-ray source and the detector to rotate clockwise and counterclockwise para hindi mabuhol-buhol yung wires. Yun. Ang disadvantage lang ng third generation clinical CT scan is ang ring artifact. So, yan. So, ring artifact occurs due to miscalibration or failure of one or more detectors. So, since isang set lang man of detectors, so there are times na mag-miscalibrate yung detectors, that is why it would cause a ring artifact. So this is not the exact image produced by the third generation CT scan. I just want you to see how a ring artifact looks like. So ito. This is called a ring artifact. It is caused by miscalibration or failure of the detectors, one or more detectors. Yan. So the third generation CT scanner is designed to have a thin tungsten septa placed between each detector in an array and focus the X-ray source. This is to reject the scatter radiation by detectors. So, 'di ba, ang main problem sa second generation na CT scan was scatter radiation. So, for this generation of CT scan, in-address nila yung um, problem sa scatter radiation. Now, they've incorporated thin tungsten septa between each detectors. Yan. So, yan ang improvement ng third generation na CT scan. Ngayon, ang problem naman nila is ring artifact. Okay, so let's move on to the fourth generation. So, to combat the flaws of the previous generation CT, it was modified, di ba? Ang problem nila is ring artifact, di ba? So, the fourth generation was modified to use a stationary detector in the form of an enclosed ring surrounding the entire patient. So in contrast, the X-ray tube still rotates around the patient, projecting a fan of X-rays that sweeps the detector rings as the source rotates. So ang mechanism na ng fourth generation clinical CT scan is rotate stationary. So, yung X-ray source na lang ang nagro-rotate, yung ring of detectors is stationary kasi 'di ba provided na ang entire um, circumference ng iyong CT scan. So, ang good thing lang sa fourth generation, in-address naman nila yung problem sa third generation CT scan, 'di ba? Ang problem nila is ring artifact which is caused by miscalibration or failure or malfunction of one or more detectors, 'di ba? So, they've addressed the problem by having self-calibrating system. So, itong self-calibrating system, the detectors calibrated twice during each rotation of the X-ray source. 'Di ba ang third na generation na CT scan automatically calibrates only once lang every few hours. So in fourth generation CT scan, they've addressed the problem with ring artifacts by putting in self-calibrating system. So, isa pa sa pros nitong fourth generation is it allows higher number of projections per rotation. 'Di ba? As unlike in third generation scanners, the sample spacing is not dependent on the detector element size. So this advantage allows a reduction of aliasing effects and allows the detector to be recalibrated dynamically as each element is exposed. So, ang cons naman or ang disadvantage ng fourth generation CT scan is a very large number of detectors na i-require niya, 'di ba? Kasi meron mang complete ring of detectors to accommodate the patient. So, as the number of detector increases, it carries a substantial cost. Mahal dyan na siya. So mag-increase din ang cost. And so in medical practice, so if sa hospital pa yan siya, hindi siya justifiable. So it is very difficult to justify purchase of fourth generation scanners given the limited associated advantage. So yun ang kanilang concern. And also, fourth generation scanners are therefore less siya popular kasi nga mahal siya. So as compared sa other generation ng CT scan, itong fourth generation ang hindi masyadong popular because of its cost. And isa pa, scatter radiation as a detector element must be as each detector element must be able to detect X-rays from a relatively wide angle. So this requirement allows for scattered X-ray to reach detector elements and distort the scan data with no simple method of reducing this problem. So scatter can be corrected for using post-processing algorithms or reference detectors, but both of these corrections carry the caveat of increasing the time taken in reconstructing images. So yun, mas taas ang kanyang patient dose because of the scatter radiation kasi nga, habang umiikot itong X-ray source, hindi siya mag-stop na mag-emit ng X-ray, di ba? Hanggang matapos niya itong entire rotation. So, ang con nito, isa sa major cons, aside sa mahal siya, is ma high kaayo ang patient dose, mataas ang patient dose. Let's move on to the fifth generation. So we all know that both third and fourth generation scanners are ultimately limited in their ability to decrease scan time, diba? And as the maximum rotation speed of the gantry is limited by the maximum centripetal force, it is possible for the equipment to experience. So in the early 1980s, the fifth generation CT scanner was invented specifically for inspection of patients' hearts. So the electron beam, um, the fifth generation has a mechanism of electron beam. Electron beam ang kanyang major na gamit. Okay. It was also known as ultra fast CT scanner or electron beam CT or EBCT or Cine CT. So it was developed or introduced by Andrew Castagnini. So it was specially made for um, investigating or scanning the heart. So ang fifth generation CT scan does not use a conventional X-ray tube. So ang ginagawa dito, so here's an electron gun, and ito ang design niya. There is an electron gun, merong focus or coil, merong deflection coil. So ang ini-emit ni gun, di ba, is electron beam. So around this, meron ditong large arc of tungsten. So pag meron na pag matamaan yan ng electron beam, yung tungsten, di ba, it would emit X-rays. So para real-time siya, real-time ang kanyang acquisition. So here, the X-ray would deflect here. It would go through the patient. It will be detected by the detector ring, and it will be translated by the data acquisition system. So yan siya. Ganyan ang unique na design ng fifth generation CT. Yan. Yan, electron gun produces a focused electron beam and generate a rotating X-ray fan beam. This fan beam are produced after being steered along the tungsten ring. Yun yung aking explain kanina. So from the electron gun, dadaan siya dito sa focusing coils. It would go down, merong bending coils. Tatama siya dito sa tungsten, and then it would go through the patient. It will be detected by the detectors, and it will be translated by the data acquisition system. Yun siya. So, yeah. The fifth generation CT scanner was invented specifically for cardiac studies. So, yan ang kanyang design. So, it is specifically designed in such a way that no mechanical movement of the source, detector, or patient is required. So, steady lang ang fifth generation CT scan. So, ang gina-require na time to snapshot a cardiac motion is below 15 milliseconds. So this machine or this generation is capable of that. So, yan. Okay. Now, let's move on to the sixth generation CT scan. So, the sixth generation CT scan is also known as the helical spiral helical or spiral CT scan, or volumetric scanners. So this was in early 1990s, this was introduced, or most of its development were led by these two people, Willie Callender and Kazuhiro Katada. So yan ang mga major contributor ng sixth generation CT scan. So in conventional CT, the tube and detectors moves clockwise and counterclockwise in 360 degrees. Diba? Yun yung sabi ko, to prevent tangling of the wires. Diba? They would require that. Diba? And ang scanning lang niya is paikot lang talaga and counterclockwise. While in this generation of CT scan, the tube and detector arrays continuously move with the table. So, kaya siya tinawag na spiral kasi para siyang spring na ganyan, paikot siya. Simultaneous ang pag-ikot ng tube at ng detectors while the table is moving. So in short, the helical CT acquires data while the table is moving. Ganyan. Yan. So ito. So, let's just say, ang table, ganyan ang movement, diba? So, the X-ray tube would turn around the patient, rotate around the patient. So, yan. Ito ang itsura niya. Mag-spiral siya, move ang table. So, the design of sixth generation clinical CT scan is that the X-ray tube rotates as the patient is moved smoothly into an X-ray scan field. Simultaneous source rotation, table translation, and data acquisition. So, sabay-sabay itong nangyayari, yung pag-ikot ng X-ray tube, pag-move ng table, and pag-acquire ng data. And also, this generation of CT scan produces one continuous volume set of data for entire region. So, pwede mo na ma-scan ang whole abdomen in just one acquisition with this generation. So data per multiple slices from patient acquired at 1 second per slice. So imagine it's very fast. And so by avoiding the time required to translate the patient table, the total scan time required to image the patient can be much shorter. It could be approximately 30 seconds for the entire abdomen. So, diba, entire abdomen na, 30 seconds lang. And consequently, helical scanning allows the use of less contrast agent and increases patient throughput. So, mas marami kang masascan na patient with this generation. And konti lang ang nire-require na contrast since the scanning is very fast naman, is the contrast could be easily detected without requiring you to add big volume of it. So this generation of CT scan has three major technological developments. First is the slip ring gantry designs. Second is it has very high power X-ray tubes. And third is interpolation algorithms, to handle projection data. So what is slip rings? So ang slip rings, it is around the gantry. So slip rings are circular electrical conductive rings and brushes which transmits electrical energy across moving interface. And it allows scan frame to rotate continuously with no need to stop between rotations to rewind system cables. So, ang sixth generation CT scan, wala na siyang cables. So, hindi na siya prone to, or hindi na dyan siya mag-tangle ang wires. They are using slip rings to power up the system, itong nasa loob ng gantry. So, there's no need to worry about the cables. Yan. So, ito ang slip ring. Ito ang slip ring. So, ito ang brush. So, dyan lang nag-transmit ng electricity. Wala na siyang cables. So, it was made possible by slip rings. It was called slip rings kasi ito ang slip ring. Ito naman ang brush. Yan. And it allows continuous gantry rotation. So, ano naman ang interpolation? Interpolation methods were developed by calendar. These are used to generate projections in a single plane, and the overlapping sections generated by math, not beam. Not beam improves z-axis with no increase in dose, which helps in improving image quality. So in simple words, interpolation algorithm converts volume data into size images. So yan lang ang kanyang, um, di ba, ang pag-acquire ng image sa helical city, di ba, is spiral. So, ang interpolation is basically a mathematical algorithm. It's more on the post-processing. So it is made possible. So to reduce artifacts due to table motion during spiral scanning, we use a special reconstruction process called interpolation. So this data were converted to slice images dahil yan sa interpolation. Now, what is pitch? So in helical city, pitch is the ratio of patient's movement through the gantry during one 360-degree rotation relative to the beam collimation. So basically, pitch is a distance in millimeters that the table moves during one complete rotation of X-ray tube divided by the slice thickness. So yan ang formula ng pitch. So ano ba ang mangyayari? Ano ba ang effect ng pitch? So increasing the pitch by increasing the table speed reduces the dose, reduces radiation dose. So if you increase now the table speed, it will reduce the the radiation dose of the patient, and it will increase the pitch and it will decrease the scanning time. But, ang mangyayari lang dyan, oo, maganda ay yung pitch, malakas ang table speed, mababa ang radiation dose, mababa din ang scanning time. Ang drawback lang yan, it would compromise the image quality or the image resolution. So, ito. So, in helical city, so yun ang sabi, ang ratio ng patient's movement through the gantry during one 360-degree rotation relative to the beam collimation. So, this is the formula for pitch. Sa helical city ito. Pitch is equivalent to table movement per rotation divided by slice collimation. So, for single slice city, ito ang formula. It's different. Pitch is equal to the table movement per rotation divided by slice collimation. So yan, TF divided by N times SC. So where TF is a table feed in millimeters per 360-degree rotation, and N is the number of detector rows, SC is the slice collimation in mm. So anong mangyayari nito? This is an illustration. So this is a pitch of less than 1. So the beam width has some overlap at each view angle from rotation to rotation. So yan, possible na mahina ang movement ng iyong table, and most likely mataas din ang patient's dose ng, ang radiation dose ng patient, So yan ang itsura or illustration ng less than 1 ang pitch. So ano naman ang mangyayari kung 1 ang pitch, exactly 1 ang pitch? There is no overlap of beam width at each view angle, and no view angles not covered at certain table positions. Exact man jud kaayo no, walay gap. Ayan. Ano naman kung greater than 1 ang pitch? So some view angles are not covered by the beam width at certain table positions. So, ganyan. Mabilis ang speed ng table. So, most likely, mababa din ang image quality nito. So when pitch is greater than 1, there are interspaces created and some portion of the body is being missed. 'Di ba? Meron siyang na-miss dito. Kasi nga, malakas or mabilis yung movement ng table. So that is why it would lead to low image quality or low image resolution. Kasi nga, meron mang gap. Pag exact 1 ang pitch, perfect na perfect, walang gap. So ano ba ang advantages ng Spiral City among other generations? So first, na advantage niya, it has faster image acquisition kasi nga simultaneous ang pag-ikot ng tube, pag-detect, and pag-move ng table. It has quicker response to contrast media. It has fewer motion artifacts kasi nga mabilis. Improved two-axis resolution. Physiological imaging, you can see the function of an organ or certain structure. Yan. And it has improved coronal, sagittal, and 3D imaging, and it has less partial volume artifact. So we will discuss naman the 7th generation clinical CT scan. So it has a mechanism of sweep translation. So ang 7th generation clinical CT scan naman, it has multiple detector array or commonly called the 64 slice CT machine. It has multiple detectors, multiple detector array, and 64 slice CT. So ang unique dito sa okay. So when you say, 'di ba, meron tayong different types of CT scan, 'di ba? We have 32, we have 64 slice, 'di ba? Common yan siya na description ng isang CT scan. So, ang thinking natin, mas mataas ang slice, um, mas maganda ang image quality. So when you say slice, 'di ba usually imagine nyo na, ay parang baka sa isang scan 64 slices ang ma-acquire niya. So hindi pala yan siya sa literal na slice. Ang 64 slice, when you say 64, the number of detectors. So if it's 1 to 8, 1 to 8 ang detectors niya. So it has multiple rows of detectors. So 1 to 8 nakabuo. And then when you say 256, that machine has 256 number or 256 detectors. So, yan siya. So, as you can see in this view, meron tayong 4 rows or 4 arrays of detector. Yan siya. So, so individual detector, naka-line up dyan. So, multi-slice CT. So, it has multiple array of detectors. Yan, yan. So, ano ba ang multi-slice CT? So, this relates to the technique of double or triple rotation of the tube and detectors around the same axial plane. And also, this CT provides double or triple of the volume per slice, upon which the final image can be derived. In practice, each rotation produces its own bank of raw data. So, kaya siya maganda ang quality kasi marami siyang ma-acquire na data, 'di ba? It could provide daw double or triple the volume, 'di ba? If you compare it with a single row of detectors, now this CT could produce double or triple of the volume. Kaya mas maganda talaga ang image quality. So, multi-scanning therefore reduces motion artifacts, 'di ba? Kasi nga marami ka nang ma-acquire in just a single sweep, 'di ba? So, in short, less na ang chance na meron pang motion artifact. And consequently, this improves image quality. So, there is also development in software sa itong multi-slice CT. And also, there's development in the computer capacity kasi mas maraming data, mas mabigat siya. So, dapat mas malaki din yung capacity ng iyong computer to process the data. And this led to processing and reconstruction in short time. So together with incorporating multiple detectors, syempre, the software and computer should also improve. So, if maganda na yung marami na yung detectors, dapat mas maganda din yung computer and software capacity para ma-process and ma-reconstruct yung iyong data in just a short period of time. Again, this is a single slice. When you say single slice CT, one slice lang, there is one long detector lang ang kanyang meron, but it's just one row. When you say multiple slice CT scan, there are multiple rows of detectors. Yun siya. So I hope you've understood the main difference between single slice CT and multiple slice CT. So that ends my lecture. I hope you've learned a lot and see you on my next video.